Hi, I'm Nikita Kowal and I lead the Concurrent Computing Lab at JetBrains Research. Let's start with a brief overview of the lab. In short, we have three main objectives. First of all, we focus on practical-oriented algorithms and data structures that we need at JetBrains. In particular, synchronization communication primitives that we use in Kotlin coroutines. Secondly, we develop tools for testing and verification of these algorithms. Later, we'll discuss LinCheck, a framework for writing concurrent tests. Also, we work on fundamental problems, such as classic algorithms and their formal proofs and analysis. Let's look at some of the projects closer. The lab itself was established about an year ago, but the story began much earlier with the project on new communication and synchronization primitives for Kotlin coroutines. In particular, we proposed a new algorithm for channels. These are special primitives to transfer data between coroutines. And this algorithm is going to be a part of Kotlin coroutines in the nearest future, and it will be released soon. Also, we have a paper under submission on this work. While working on the channels algorithm, it turned out that it requires proper tooling for testing and verification. Otherwise, it's almost impossible to ensure correctness of your algorithms. That's why one of our primary projects is the LinCheck framework, which allows you to write concurrent tests in a simple and declarative way. In short, you simply specify a set of operations to be examined, and after that LinCheck automatically runs a bunch of tests and provides a trace of incorrect execution if an error is found. Initially, the LinCheck framework was designed for the JVM platform. However, one of our recent projects aimed at porting it to the C++ world. And we can achieve this by maintaining the code base in Kotlin and using its multi-platform feature. So we already have a prototype that works pretty good on C++, and we hope that this feature, the beta version, will be released in the next year. Similar to testing, it's also important to perform performance evaluation. And one of our in-development projects is a special tool for benchmarking, which also provides a declarative way to write benchmarks. It, first of all, automates the benchmarking procedure, but also offers some additional features, such as benchmarking via sampling, so that you can approximate graphs using these samples and also optimize the environment configuration automatically. This simplifies the process and speeds up a lot. Additionally to the discussed projects, we work on other fundamental problems, such as parallel graph processing and recoverable algorithms for non-volatile memory. We have several papers on these topics published or under submission this year. How these papers will be accepted? I would highlight one of the under submission papers, which improves the priority scheduling for graph processing algorithms. One intriguing existing design is the multi-queue. Given m sequential queues guarded by locks, priority queues, insertions are performed into a random queue, while delete picks two random queues and removes a task with higher priority. Interestingly, this design provides good fairness guarantees, yet the multi-queue performance is below that of well-engineered schedules. So we propose a new version, which we call stealing multi-queue, a cache-efficient version of multi-queue which leverages both task batching and queue affinity. When each thread has its own local queue, and it works with this local queue, but from time to time it steals tasks from the other queues if they have higher priority. We also proved that these relaxations keep fairness guarantees. Our implementation of the proposed algorithm is well optimized, so it can surpass the state-of-the-art priority schedulers on popular graph processing benchmarks, providing a much simpler solution at the same time. In fact, that's what we usually do in the lab. We pick an academic problem and apply industrial techniques to solve it, even when we work on a completely new algorithm from scratch. To summarize, our lab mainly focuses on practical algorithms and data structures, as well as on tools for testing and benchmarking them. Most of the research artifacts, such as the LeanCheck framework, are either widely used in and outside JetBrains, or we will productize them in a little while. Being a part of JetBrains research also brings us an opportunity to make the tools we are working on better by collaborating with the IntelliJ team and integrating them into our IDEs. That's what we want to do in the next year. Of course, we won't stop working on algorithmic problems, improving classic data structures and designing new crash-resilient algorithms for non-volatile memory in particular. To sum up, we will continue building a bridge between the industry and the academy and hope we'll get as much A and A star publications as possible. I hope you enjoyed the highlights, and if you have any questions, don't hesitate to ask me.